Hi everyone. So going to be doing something a little bit different today. Recently our pen testers discovered this weakness with our antivirus solution. We use Webroot and they've identified this weakness whereby if you copy and paste some malicious code directly into a PowerShell window, the antivirus solution does absolutely nothing to stop it. It will just run, and whatever malicious code it is that's being executed is not stopped in any way by our antivirus. It's interesting because if you can take the exact same code and put it inside a PowerShell file, a PS1 file, and within a few minutes the antivirus will detect the file and quarantine it, which means it obviously does detect the malicious code as being malicious. So it's interesting, yeah, for me, even the code just being in the clipboard should be an issue really for any modern antivirus solution. Anyway, I've tested it myself and sure enough I'm finding the exact same behaviour. So what we'll do now is we'll swap over to a test environment where I've got this set up, and we'll go through it. And it is interesting because according to our pen testers, not all antivirus solutions do suffer with this weakness, but Webroot's definitely one, and apparently Windows Defender is as well. Anyway, I'll swap over to my test environment now and we'll go through it, so see you there. Okay, so here we are with my lab environment set up, and what we've got here on the left hand side is just a Windows host running, so it's Windows 11, and this would be this potential victim's computer, and then on the right hand side here what we've got is the attacker's computer. So typically you've got to imagine that these are two separate systems, so you've got the victim on the left and the attacker on the right. And the trouble is, like I said, is at the moment in Windows it's got this vulnerability, at least Webroot does, it's got this weakness where I can run some malicious code directly in a PowerShell window. So typically the way you would be infected is you would receive something, an attachment on email or something, you run it, and then there you go, you've given some attacker some level of access. Whereas this vulnerability is interesting because the code I'm about to run, if it's inside a vulnerable PowerShell file, a PS1 file, Webroot will detect it and block it in about a minute or two. But if I take the code out of that file and paste it directly into this window, it connects through, and it doesn't get stopped in any way. Which, yeah, to be, is quite a big weakness, because you could essentially maybe find a way maybe to send someone some plain text code and just say, oh, will you do me a favour, would you open a PowerShell window and put this code in? And someone just in all innocence goes, yes, of course, no problem, and does it, and then they've granted someone access. They've given them a way in. So anyway, yeah, left hand side victim, right hand side attacker. So the way this usually would work is the attacker sets up some kind of listener, so that when the victim runs some kind of code or executes a file or something like that, that then establishes a connection back to the attacker, lets them in. So the way that works is the attacker will set up a listener, and then they'll listen for a connection from that is generated by the victim. So what we'll do now is we'll set up the listener, and for that we're going to use Metasploit. So by the way, as well, some of you might be wondering, saying, well, this isn't fully on, there's all that, but it is. Real-time shield's on, web shield is on, it's only the firewall that's off. And the reason why the firewall is off is because we use Windows Firewall. Reason being is there's a lot more configurable. The Webroot firewall we have here is essentially on or off. You can't make any customized rules with it or anything. So yeah, we've got a Windows Firewall for that.
Just to add a quick side note in here, it's worth noting that I have also done this test with Webroot Firewall switched on, and the behaviour was the exact same.
Anyway, we're now, as you can see, we're now in Metasploit. So what we're going to do now is set up our listener. So for that, we need to set up a multi-handler. We have some options in that we need to set. Yep, so we need to set the local host, which is the host we're going to listen on, which is going to be this computer. As we're doing this, as this is a local attack, we'll just use my local IP address, which is 192.168.0.39. If you were doing this over the internet, obviously you'd be using your public IP or whatever, which would presumably you'd be doing through some kind of VPN or other to hide your identity a bit. Anyway, yeah, this is just a simulation, so we're just going to use the local IP. So what we need to do is set the local host to that. There we go, the port's fine. Pretty sure that's what the payload I've generated already uses anyway, or the malicious code if you like. So now what we need to do is set the type of payload, what sort of target we're going to be attacking, because at the moment it'll be using a generic shell reverse. Now what you can do is if you tell it what sort of host you're going to be attacking, you get a lot more options, so it'll tell it what sort of attacks you can do, etc. So we'll set that as well. So set payload Windows 64, it's going to be an interpreter and it's going to be a reverse TCP, so we'll set that. Now that's set, we can just simply run the command exploit. And now what this is doing is this is listening. So this is now listening for a connection on this address via port 4444. So the attacker's established their listener. They've now sent over some kind of dodgy code to the poor victim, who's now going to run it in PowerShell. So I can show you the actual payload I've generated. So it's this here, this PowerShell reverse TCP1.ps1 file. Now the interesting thing is, if I was to actually copy and paste this file over to Windows, and it is very much just a file. Like I said, Webroot will detect it. It will detect it and it'll delete it, it'll quarantine it. However, if I simply view the code inside the file, there we go, right. So if I copy and paste this code in, so copy. Now already that's in my Windows clipboard. Webroot's done nothing. That is the same malicious code that it will detect inside a file, but inside the clipboard it doesn't do anything about. But I can go one step further. Watch what happens here now as soon as I paste this in here. And there we go. What that's now telling us is it's received a connection from the victim's computer, which is running now, and we have now got access to their computer. And just to demonstrate that, if I go into the actual command line of the computer and type something like Notepad in, there it goes, it just appears up. So that's how much level of control we've got. Now admittedly, I haven't done any kind of privilege escalation attack here, so if I was to try and go into try and actually go into Windows, and then try to make a directory, it's not going to let me. It is going to get access denied. And this has a command where you can do something like get system, and then it will try and do a bunch of privilege escalation attacks, which apparently it has actually managed to do. Interesting. And again, Webroot hasn't done anything about that, and now I've got elevated privileges. It is quite incredible how much level of control you get. So if I do another command, record from microphone, start a chat. Here we go, there's one that I always like. Watch the remote user of a desktop in real time, screen share. And there we are, looking at the Windows attacker. In theory, this will refresh on a period and you'll see it happen, but yeah, so you can see it slowly updating. So now I'm even spying on the poor victim. So yeah, not good. But apparently Windows Defender also suffers with that same weakness. Now thankfully most of the time these terminals are not going to be running as an administrator, but should it be someone's personal computer where it's not password protected, all the attacker would have to do is send over the code in plain text and say, oh, by the way, when you paste it into an administrative PowerShell window. Right click on it, run as administrator. They click yes on that, they paste the code in, and all of a sudden this becomes a lot more scary, because not only do you have access, you have administrative access, and you don't even need to do any kind of privileged escalation attack. You will already just be in as an administrator, so you've just completely... The computer is no longer the poor victims anymore. It belongs to you, it belongs to the attacker. So yeah, I just thought I would show that because it's interesting. For anyone else who has this weakness with their AV, what I would recommend is that you use a group policy to restrict the use of PowerShell altogether if you can. Unfortunately, this isn't going to be an option for all companies and things, because if you use PowerShell a lot for part of your operations, then that's going to cause you a major issue. So for you guys, you might be looking at some kind of alternative solution, whether it be an alternative antivirus solution, I'm not sure. All I can tell you is that apparently, according to our pen testing company, not all antiviruses do suffer with this weakness. So definitely one to keep an eye out for. I've only tested this against Webroot and Windows Defender so far. For us, what we've done is we've restricted the use of PowerShell altogether except for administrative accounts. It's a pointless thing really, because only administrators can log into the servers in the first place anyway. However, it's still a vulnerability that exists, so therefore it comes up on pen test report and it comes up as a high risk. Use group policies or app locker or something like that. Anyway, I hope you found this as interesting as I did. I just wanted to show it off because do something a bit different as well. So yeah, I hope you enjoyed the video, and I will see you in a future one. So thanks, bye bye.